Okay, moving on to problem 4. It's just like problem 3 and 2. Same exact problem, maybe a slightly different measurement of the pressure at point A. Now it's 4,100 pascals. And now we are told to use the water table as the datum. All right, so once again, we're going to write the two equations we need. H equals Z plus psi. And we know that psi is equal to P over rho. That's density times G. Hopefully those symbols are clear. So at point A, we're given the metric potential. I'm sorry, no, we're not. We're given the pressure as negative 4,100 pascals. We have to calculate the metric potential. So let's write this down. The psi at point A will equal the pressure at point A divided by rho G. And that will equal negative 4,100 pascals. Everything in MKS, remember, divided by 1,000 kilograms per cubic meter. That's the density. And 9.81 meters per second squared. That is G. And if I plug that into my calculator, I end up with, let's go make sure here, I end up with psi of negative 0.42. Negative 0.42 meters. That is the head. I'm sorry, that is the psi. What am I saying? Psi at point A, negative 0.42 meters. Now to determine the head, I first need the elevation, and we are to use the water table as datum. So here is my datum. Let me color it red here so that we are on the same page here. So this is now my datum here, right? That is my datum. Okay, so we can count this out. Once again, remember these little lines are 10 centimeters apart. So relative to datum, we are 10, 20, 30, 40 centimeters, 40 centimeters above the datum. So that produces a Z for A is equal to positive 40 centimeters. Remember that there are 100 centimeters in a meter. So that is the same as, let me write this down there, 0.40 meters. And the reason I'm converting it to meters is because my psi was in meters, and these need to be in the same unit in order to add them like I do here, right? So when I get them done, I have the H, the head at A, equals Z, which is positive 0.40 meters, plus psi, which is negative 0.42 meters. And that is going to equal the very small number negative 0.02 meters. It's almost zero, just a little bit below zero. Okay, now to solve the problem. So there's the first answer to the problem. Second one is to determine which way water is flowing, either between the water table and A, whether it's flowing down or up between A and the water table. So to do that, once again, we need to determine the head on the water table directly below A. Now, in this case, it's going to be incredibly easy because we have stipulated that the water table is datum, right? So the water table is datum. So the head at point B here, head at B, will equal the elevation of B relative to datum, Z, plus psi at B. Psi at B is easy, remember, because psi is always equal to P over rho G, and on the water table, pressure is equal to 0, so psi is always equal to 0, always on the water table. No matter what we choose as datum, the metric potential on the water table is 0. So in this case, we have that, or in all cases, the head on the water table at point B will equal the elevation of the water table relative to datum, but we've chosen the water table as datum. So in this case, because I've chosen the water table as datum, Z is equal to 0 as well. So the head at the water table at point B is just equal to 0 plus 0 equals 0. So how easy is this now? So the head at A was equal to negative 0.02 meters, the head at the water table was equal to 0. We didn't even really need to calculate it. If we define the datum as the water table, then we basically can write it down as 0. Now, however, we can't define the datum as the water table for the purpose of calculating the head at the water table, and then define the datum as something else for the purpose of calculating the head at A, for example, right? So if we're going to use the water table as datum to calculate the head at the water table, we have to use the water table as datum to calculate everything else, which we've done here, right? We calculated a head of negative 0.02 meters at point A using the water table as datum. And so now we can see that the head is larger at the water table than it is at point A. It's slightly larger, and so water will flow upward from the water table towards point A. Sort of the point of this problem was to realize that if we define the water table as datum, then we are going to find that the head on the water table is 0. And we then need to go calculate the head at any other point using the water table as datum, and we can rather quickly determine the direction of groundwater flow.